Look, when you're talking about high-stakes projects, vague labels like high risk just don't cut it. They're not good enough. So today, we're going to demystify quantitative risk analysis. It's a powerful method for turning all that uncertainty into hard numbers, so you can make smarter, more strategic decisions when it really, really matters.
All right, here's our game plan. First, we'll talk about why we even need numbers to begin with. Then, we'll define what this whole process is. After that, we'll open up the toolkit, learn how to make sense of the results, and most importantly, finish up by turning all that great analysis into real, decisive action. Let's dive in.
Okay, first things first, let's just set the stage here. When you've got millions of dollars, maybe even your company's reputation, riding on a project, you can't just rely on gut feelings or simple labels. That's just not going to fly. We have to get way more specific.
I mean, really think about it. What does high risk actually mean? Does it mean we're going to be a week late or 6 months late, $1 million over budget or 10 million? See, these vague labels, they hide the real story, and that can lead to some seriously bad decisions. We need a much more precise language, one that speaks in numbers, probability, and financial impact.
This slide right here really gets to the core of it. Qualitative analysis, absolutely essential. It helps you rank your risks. It answers the question, okay, which of these fires should we put out first? But quantitative analysis, that takes the crucial next step. It pulls everything together to answer the big, multi-million-dollar question. What is the total potential impact of all this uncertainty on our project's bottom line?
So what is this thing exactly? Let's put a clear definition on it. And here it is, the official definition from the PMBOK guide. Now, the key phrase you've got to lock onto is combined effect. This isn't about looking at risks one by one, in a vacuum. It's about understanding how they all tangle together, how they interact and compound to affect your final cost and your final delivery date. It's about seeing the entire forest, not just a few scary-looking trees.
Now, let's be clear. This isn't something you're going to use for your weekend DIY project, right? This is the heavy machinery. It's a tool you reserve for situations where the complexity and the strategic importance really demand it. If your project is huge, if it's a game changer for the company, or, if a client or a contract just flat out requires this level of rigor, well, then it's time to bring out the quantitative toolkit.
So how is this analysis actually done? Let's get our hands dirty. It's time to open up the toolkit and see exactly how we turn these abstract risks into cold, hard numbers.
The biggest mental shift in this whole process is right here. We have to stop pretending we have a crystal ball. So instead of saying, this task will take exactly 5 weeks, we get honest about the uncertainty. We define a range. What's the best case scenario, the worst case, and what's the most likely outcome? This range gets captured in something called a probability distribution, and that becomes the fundamental building block for our entire analysis.
And this brings us to our first major tool. It's an incredible forecasting technique that lets us simulate the future. So here's the question. How in the world can we test drive our project thousands, even tens of thousands of times before we've even spent a dime?
The answer is the Monte Carlo simulation. Here's how it works. First, you build a basic model of your project's cost and schedule. Second, for every single task, you plug in those probability distributions we just talked about, the best, worst, and most likely cases. Then, you let the software go to work. It runs the project simulation, say, 10,000 times, and in each and every run, it randomly picks a value from within your ranges for every single task. And finally, it gathers up all those thousands of results to give you this amazing statistical picture of what's probably going to happen.
Okay, so the simulation gives us our total risk exposure, which is awesome. But that's only half of the story. We still need to know which of our risks are the big drivers. Where are the real monsters hiding? Where should we focus our energy to get the biggest impact? For that, we use something called a sensitivity analysis. This technique is brilliant. It basically tests each risk one by one to see how much it moves the needle on the final outcome. It pinpoints the most critical variables, and the results are usually shown in this really powerful chart called a tornado diagram.
And bam, here's what that looks like. You've got the risks stacked up with the longest bars at the top. Those are the ones with the biggest potential impact on your project's cost. You can see instantly that permitting delays and a key supplier failing are our biggest threats. The beauty of this is its clarity. Out of maybe dozens of risks, this chart tells the team, hey, focus right here. If you solve these two problems, you're going to get the biggest bang for your buck. All right, the final tool we're going to look at helps us when we're at a crossroads. And let's face it, projects are full of these moments. Do we build a whole new facility or just upgrade the old one? Do we go with technology A or technology B? How do we make that call when the future is so uncertain?
We use a decision tree. This gives us a structured, visual, and most importantly, mathematical way to compare our choices. It maps out all the potential outcomes for each decision, assigns a probability to each one, and then calculates a financial value. This gives us what's called the expected monetary value, or EMV, for each path we could take.
So let's look at this example. Building a new plant, it has a huge potential payoff, but wow, also a pretty significant potential loss. Upgrading is the safer play. So when we do the math, multiplying the outcomes by their probabilities, the result becomes crystal clear. Even though the build option has a higher ceiling if things go great, the upgrade option has the higher expected monetary value, $46 million versus $36 million. It's the strategically better financial decision once you actually account for all that uncertainty.
Okay, let's see how this all comes together. We've run the models, we've done the math, but what do the results actually look like? How do we turn all this complex data into clear, actionable intelligence that our stakeholders can actually use?
This is where the rubber meets the road. The output of our Monte Carlo simulation is designed to answer the one question every single project sponsor is going to ask: are we going to hit our targets? But it answers that question with a level of nuance and honesty that a single number just never could.
And the answer comes in the form of this chart, a cumulative probability distribution, which you'll often hear called an S-curve. Along the bottom, you've got the whole range of possible project costs, and up the side, you have the probability of finishing at or below that cost. It's a complete probabilistic forecast for your project.
So, let's say our initial target cost was $2.2 million. We can go find that value on the chart and look across to see the probability. In this case, the analysis tells us we've only got a 23% chance of hitting that target. Now that is a sobering, absolutely critical piece of information that completely changes the conversation with your stakeholders.
But we can also use it to answer a more constructive question, like, okay, what budget do we need to have an 85% confidence level of success? We just look at the chart, and the model tells us we need $2.45 million. And that difference, that $250,000 between our original target and this new, more realistic number, that right there is our data-driven contingency reserve. So you see, the final output isn't just a pile of data, it's a strategic brief. The updated risk report delivers clear, quantitative answers. What's our real likelihood of success? What's the precise amount of contingency we need? Here's a prioritized list of threats from our sensitivity analysis, and here's a clear picture of what's driving our overall risk. It's a battle plan.
And that brings us to our final and maybe most important section. All this analysis is completely useless if it doesn't lead to action. So let's close the loop and see how these powerful insights directly drive what the project team does next.
The workflow from here is actually pretty clear and logical. You start with that prioritized list from your tornado diagram, and you develop very specific response plans for those biggest threats. You take the contingency reserve you calculated from the S-curve, and you formally add it to the project budget and schedule. And finally, you update all your project plans, making sure these data-driven decisions become the new official plan of record. You know, this whole process really comes down to a fundamental shift in how you think. The goal is to transform risk management from this reactive, box-ticking exercise into an essential tool for leadership, something that gives you genuine foresight and allows you to take proactive control over your project's destiny.
And that leaves us with one final thought to take away from this explainer. The difference between just listing your potential problems and actually quantifying their combined effect, well, it's profound. Using numbers allows you to move from simply reacting to risks to proactively engineering the conditions for your project's success.